All right, today we're going to pull back the curtain on the super fast-paced world of software. We're going to demystify this whole thing called DevOps by following the journey of just one feature, from a simple idea all the way to your screen. Let's dive in.
I mean, have you ever really stopped to wonder about that? You open up an app one day and boom, there's a new button, a fresh look, some cool new thing you can do. It kind of feels like magic, doesn't it? Well, it's not magic. It's actually a really cool, carefully orchestrated process. And today, we are going to break down exactly how that magic works.
So, first things first. Let's start with the big idea behind it all. What on earth is DevOps, anyway? Okay, now look at this. The very first word here is culture, and that is so important. See, DevOps isn't just a tool you can buy or another job title you can get. It's a fundamental shift in how people think. It's all about breaking down those old imaginary walls between the people who build the software, the devs, and the people who have to run it and keep it stable, the ops. The whole point is getting them to work together as one team.
And why bother doing all this? Well, it all boils down to this one simple, incredibly powerful goal. By working together, teams can push out new features and bug fixes faster than ever before. But, and this is the absolute key, they can do it without everything crashing all the time. It's about getting both speed and reliability, the best of both worlds.
Okay, on to section 2, from code to commit. Our journey really begins the moment a developer sits down to write some code. But think about it, how do you manage the work of dozens or even hundreds of developers all working on the very same project? The answer is something called version control. And honestly, the best way to think of it is like a time machine for your code. I'm serious. It's a system that records every single change, who made it, when they made it, everything. This means teams can collaborate without accidentally overwriting each other's work. And, maybe most importantly, if something breaks, you can just hit rewind and go back to a previous version that you know worked. It's a total lifesaver. Now, a super common point of confusion is Git versus GitHub. So let's clear that up. Just think of it like this. Git is the actual tool. It's the toolbox you have on your own computer for tracking all those changes. GitHub, on the other hand, is the place. It's the big shared workshop up in the cloud where your whole team stores their projects and works together. One is the tool, the other is the place. Simple as that. All right, section 3. Once a developer shares their code, it enters what I like to call the automated factory. This is where the real action begins. It's where raw code is taken, built, tested, and prepared for the world. And the best part? It all happens automatically.
And the engine that powers this factory is CI/CD. So CI stands for continuous integration. It automatically merges code from every developer and runs a battery of tests on it. This is huge because it catches bugs super early before they turn into major disasters. Then you have CD, or continuous deployment. It takes the code that passed all those tests and, you guessed it, automatically releases it out to users. This is the secret sauce. This is how you get new stuff into people's hands in a matter of hours, not months.
This whole flow is called a release pipeline, and it's like a chain reaction. A developer commits their code. Bam, the system builds it. Then, bam, automated tests run to sniff out any bugs. And if everything checks out, bam, it's deployed live for everyone to see. This entire process can take just a few minutes. It's incredible.
But hold on, what about the factory itself? You know, the servers, the databases, the networks that everything runs on. Well, in the DevOps world, we build those with code too. It's a concept called infrastructure as code, or IAC. So instead of someone manually clicking buttons in a dashboard to set up a new server, you just write a configuration file that defines exactly what you need. It's repeatable, reliable, and a total game changer.
Two popular tools you'll hear about for this are Terraform and Ansible. The difference is pretty easy to remember with an analogy. Terraform is like the tool you use to build the house. It creates the servers, the networks, the actual foundation. Ansible is what you use to furnish that house. It installs the software, applies the right settings, and gets everything configured inside.
Okay, so our feature has been built and tested, but now we have a new problem. How do we make sure it runs the exact same way on a developer's laptop as it does on thousands of servers in the cloud? This is where packaging becomes absolutely critical.
And the solution that took the world by storm is a technology called Docker, which creates these things called containers. The best analogy for a container is a standardized shipping container. You know, the kind you see on ships and trains. It doesn't matter what's inside, that box can go anywhere. It's the same for code. A Docker container bundles up the application and everything it needs to run, libraries, settings, the whole shebang, into one neat package that will work anywhere, guaranteed.
Now, you might be thinking, hey, isn't that just a virtual machine or a VM?
And yeah, it's a similar idea, but with one massive difference. VMs have to run a full, separate operating system for each application, which makes them really big and slow to start up. Containers are way more efficient. They all share the host machine's operating system, which makes them incredibly lightweight and super fast.
So, running one container is cool, but what happens when your app needs hundreds or thousands of them? You need a system to manage that chaos, and that system is Kubernetes. Think of it as the air traffic control for your containers. It's the brain of the whole operation. It decides where each container should run, it automatically replaces any that fail, and it scales your application up or down based on how much traffic you're getting.
We've reached the final stage, live and under watch. Our feature is ready for users. But hitting that deploy button isn't the end of the story, not even close. Now we have to make sure it stays up and running.
To reduce the risk of a bad release taking down the whole site, teams use some really smart strategies. There's a blue-green deployment, where they build an entire new, identical environment and then just flip a switch to send all the traffic to it. Or they might do a canary release, where they send the new feature to just a tiny group of users first, like a canary in a coal mine, to see if anything goes wrong. And then there's a rolling deployment, where they just slowly update servers one by one.
Once it's live, we have to watch it. And here's a key distinction: monitoring versus observability. Monitoring is like an alarm bell. It tells you when something you already know about goes wrong, like, hey, CPU usage is at 90%. Observability, on the other hand, is about being a detective. It gives you the tools and the data to understand why some weird, unexpected problem is happening. It helps you ask questions you didn't even know you needed to ask.
All this data helps teams manage how reliable their systems are, and it often comes down to these three terms. You start with the SLA, the service level agreement. That's the formal promise you make to your customers, like, our service will be available 99.9% of the time. To hit that promise, the team sets an internal SLO, or service level objective. That's their target. And they track if they're hitting that target by using an SLI, the service level indicator, which is the actual real-world measurement. So the measurement, the SLI, helps you hit your target, the SLO, so you can keep your promise, the SLA.
So after all that, if you asked a DevOps professional to sum up their job in just one sentence, this would pretty much be it. It perfectly captures what they do. They use automation for everything: the CI/CD pipelines, the infrastructure, the monitoring, all to make sure they can deliver software that's fast, reliable, and can scale it to meet any demand.
And there you have it, the full journey, from a single line of code all the way to a live feature, all powered by a culture of collaboration and a whole lot of powerful automation. So now you know the how behind the magic of modern software. The only question left is, what are you going to build with it? Thanks for watching.